Okay, now we are going to look at the second FRQ problem on your Chapter 3 review. Okay, we've solved a couple of problems like this. You did one in class, you had some on your related rates worksheet. So they actually provided you a picture, which is nice. It says a ladder that is 15 feet long is leaning against a building, so the end X is on level with the ground and end Y is on the wall. So they labeled that for us. X is moved away from the building at a constant rate of 1/2 foot per second. Okay, rate X. So that means that this way we have dx dt is 1/2 foot per second. Okay. Part A. Find the rate in feet per second at which the length OY is changing. So what is that? So OY is here. So they want to know what this is changing. You can call that, so changing means a derivative. So it's a d over dt. You don't have to write O and Y. You can choose one. So I'm just going to choose Y. Okay. So this is what we are finding. That's what we want to know. When X is 9 feet from the building. So we have X equal to 9. So let's see what we can do for part A. So we know X is equal to 9. Dx dt is equal to 1/2 foot per second. Y they didn't give us. That ladder is 15 feet. So let's see. If we were going to choose a formula, this is the right triangle, so we're going to be using x squared plus y squared. We'll call the ladder z. You can call it whatever you want. You call it L if you want. No one's checking your letters, as long as they remain consistent throughout the problem. So anything that does not change, well, we do. We have a ladder, 15 feet. That does not change. So before we even take the derivative, we're going to plug that in. We're going to get x squared plus y squared equals 15 squared. So we are looking for dy dt is what we want to find. So I'm going to write that here before we forget. So when we take our derivative, we have 2x dx dt plus 2y dy dt equals derivative of a number, 0. Okay, so we have x, we have dx dt. We don't have y. This was 9, this is 1/2. We don't have y, and we're trying to find dy dt, so that's going to remain. We don't have y, but we do have a way to find it. If we go back to our original formula, we can plug in x, so we have 9 squared plus y squared equals 15 squared. So here we have y when you do that. So 15 squared is 225. When you subtract 81, you're going to get 144. Take the square root, you get 12. Okay, so when we subtract that over, y is 12. So now we can plug that in. So now we have 2 times 9 times 1/2 plus 2 times 12 dy dt equals 0. And then from there, so we have 2 and 1/2, so those can cancel. So that's just 9. We could subtract that over. So we have 24 dy dt equals -9. Divide over 24, so dy dt is -9 over 24. Did they ask for units? Nope, they just said how fast, what's the rate? There we go. That's it. If you wanted to simplify this, which you have to be careful because you can leave it because it's an FRQ, but that would be -3/8 if you wanted that, okay? Now let's look at part B. Find the rate of change in square feet per second of the area. So rate of change of the area, we are finding dA dt this time. Of the triangle, so x, o, y, so they did all those points, and that's how they called it, when x is 9 feet from the building. So x was 9 feet from the building in part A, x is 9 feet from the building in part B, so we can use all of our information from part A. So area, our area formula for a triangle is 1/2 base height, but we didn't use base height. We used x and y. So let's change that before we get confused. So we're going to rewrite our area formula as 1/2 x, y. So when we take our derivative and get dA dt, I'm going to leave 1/2 out front. And then we have a product. So we have the first times the derivative of the second plus the second times the derivative of the first. Then we can plug in. So we want dA dt, so that's the only thing that's going to remain not plugged in, x, 9. Y, we got from the previous problem, we figured out it was 12. dy dt, we just figured out, -9/24. And dx dt, they gave us way back in the beginning, is just 1/2. So we have 1/2, and then we have -81/24 plus 12. 1/2 of 12 is 6. Honestly, for an FRQ, here's dA dt. Just stop here. Once you've plugged the numbers in, you could even not multiply these things together if you wanted to. Just stop there, okay? So if you really wanted to, you could, let's see, combine these things if you wanted. So we would have -81/48 plus 6/2. You'd have to get a common denominator, so you'd have to multiply both of these by 24, which without a calculator, you could make some mistakes here, so just be careful. Like if you can stop, stop. But I know some people simplified, so I want to give you the simplified answer. So we have -81/48 plus 144/48. So you end up with 63. Whoops, I said 63 and that's not what I wrote. Oh, come on. Try that again. 63/48 for dA dt. Any of these, this one would be fine, this one would be fine, this one would be fine, plugging in would be fine, as long as you have dA dt equals and it's a bunch of numbers. And then let's just check with part B. Did they ask for any units? Nope, they just said what is the rate. They didn't ask for units, so we can stop there. That's it. And that's it for this whole problem. That's part A and part B.